Hey guys, it's Mira. Welcome to the Cog-Sci Collective Special Edition. As we're approaching the end of the decade, I wanted to take this unique opportunity to go over some of the biggest Cog-Sci developments that have occurred over the past 10 years. Let's start way back in 2010, when a study showed that rhesus monkeys can recognize themselves in the mirror. Self-recognition has long been an indicator of higher level cognitive thought, and previously it had only been observed in obviously humans and several types of more intelligent apes, including orangutans and chimpanzees. But this study came out in September of 2010, and it showed that rhesus monkeys actually do recognize themselves in the mirror rather than just displaying normal social behaviors when they see their reflection. And so this evidence was really important because it showed that there is a real possibility that higher level cognitive thought actually evolved with each species of primate, from monkeys to apes and then finally to humans. Next, we'll head over to 2011, when scientists found that insects actually might have emotions. So one of the biggest problems in trying to figure out whether an animal is experiencing an emotion is that we can't actually ask the animals themselves. So we have to rely on evidence from neurotransmitters and behaviors that we can observe and measure. So in this particular study, the scientists were trying to find out if bees would have increased agitation and levels of pessimism after they were subject to a stressful environment. So what they did was they shook up a container full of bees, and then they measured the bees' levels of serotonin and dopamine, which are two neurotransmitters that typically contribute to feelings of happiness and contentment. So what they found was that the levels of serotonin and dopamine actually did decrease after the bees were subject to a stressful environment, which indicates that the bees were feeling, not too great after that stressor. And these results are interesting because it's similar to the results that we've seen from vertebrate studies, so studies with animals with greater cognitive abilities. And these findings show that insects might indeed experience emotions. 2012 was a really big year for deep learning. Because an algorithm called supervision came out that was capable of recognizing images with a very high degree of accuracy, which was something that had, up to that point, never been done before. In 2012, a deep learning algorithm won the ImageNet Large-Scale Visual Recognition Challenge for the first time. So this challenge is basically a competition where algorithms are entered and tasked with identifying and classifying various images. So in previous years, like 2010 and 2011, the error rate had been around 25%, 28%, but in 2012, this algorithm called supervision was entered into the competition, and it classified the images with an error rate of only 16.4%, which was a clear victory over all the other types of algorithms that were entered in the competition. So supervision made use of a technique called deep convolutional neural networks. Deep convolutional neural networks actually were invented in the 1980s, but this was the first time that they were able to succeed at a task as complex as image classification. And even though there have been many improvements on supervision's results in recent years, Google recently created an algorithm that has an error rate of only 6.7%. Many people consider this 2012 competition the turning point for deep learning, and the moment when people realized that deep learning actually was a viable method for complex tasks such as image recognition. Let's skip ahead to 2015, when a study came out showing that there's no definitive difference between a female brain and a male brain. The issue of whether male brains are fundamentally different than female brains has been a contentious topic since the early 1900s, because there is a lot of debate over whether men and women should be treated differently based off of the way their brains are wired. And what this 2015 study has shown is that although there are certain traits, neurological traits that are typically associated with female behavior or male behavior, those traits can be found in both male or female brains. The brain is more a mosaic of gender-related traits, and there is no definitive way of telling a female brain from a male brain. And this has interesting implications for modern ideas of gender equality. If you've ever watched the movie Eternal Sunshine of the Spotless Mind, then you know about the idea of manipulating and altering people's memories. But did you know that in 2016, scientists actually found a way to do it? This study revolved around two principles: the idea of detecting when a fear response to a memory is about to occur, and being able to override that fear response using neurotransmitters. So what the scientists did is they created a fear-related memory in the participants' brains by giving the participants an electrical shock every time they showed the participants a certain image. Therefore, the participants learned to associate that image with pain, and they would react with fear when they saw that image. What the study then did is it used an artificially intelligent algorithm to detect the brain patterns of the participant when they were about to react with fear to a specific memory. And the way it did this is by measuring brain activity in the amygdala, which is a part of the brain that is closely related to emotions of fear. And so essentially whenever the algorithm picked up that the participant was about to experience these fearful emotions, the scientists would supply the participant with neurotransmitters like dopamine that would help override that fear factor and the feelings of fear that the participant would experience. And they found that after repeated trials of overriding the fear response using neurotransmitters, they were actually able to create a long-term effect in the patient in which the patient did not respond with fear to an image they originally associated with pain. Now, this was a fairly controlled, small-level experiment, but it does suggest that in the future there could be new ways of treating fear-related mental disorders such as post-traumatic stress disorder. Although we're a long way from being able to communicate with each other telepathically, in May of 2019, a team of scientists found a way to link three people's brains, allowing them to collaborate on a game of Tetris. This technique was called Brainnet, and it made use of two neuroscience technologies: EEG, or electroencephalography, which was used to read the participants' brainwaves, and TMS, or transcranial magnetic stimulation, which was used to transmit signals to the participants' brains. So how it worked was two of the participants were senders. So they would look at at the same Tetris game and decide whether the falling block should be rotated or shifted. When they had made their decision, an EEG would read their brainwaves and then transmit those brainwaves directly to the occipital cortex of a third participant called the receiver. The receiver doesn't see the game screen, so they have no idea what's going on. But their brain receives the EEG signals from the sender's brains through transcranial magnetic stimulation, TMS, which is completely non-invasive. And when the receiver receives these signals, they then make the decision on whether to rotate or shift the block without actually being able to see the Tetris screen. And then after they made the decision, the scientists running the study observed the result on the Tetris board and determined whether the senders were successful in communicating their suggestion to the receiver. And it turned out that 5 different groups of 3 people participated in this study, and in those 5 groups there was an 81.3% success rate, which is pretty cool because it shows that brain signals can actually be transferred from one person to another person, and that one person can suggest a course of action to another person using just signals from their brain. I hope you enjoyed my overview of some of the highlights in cognitive science over the past decade. Now, obviously, I didn't have as much time as I would have liked to go over every cool, interesting study from the past 10 years. For instance, scientists found that chimpanzees like solving puzzles, which is super cool. So it's been a pretty big decade for artificial intelligence and behavioral science in general. And I'm hoping that the next 10 years will yield even more fascinating and interesting discoveries. So Happy New Year from the Cog-Sci Collective, and I hope you're as excited for 2020 as I am.